concentration, the lipid productivity, and the cellulose content in microalgae cultures to any added value in the range of the experiment. And also, it contributed to find optimal points for algae growth and the ratio lipid productivity over the cellulose content in terms of CO2 and nitrate concentration. The study of high-pressure steaming as biofuel recovery method contributed to prove the feasibility of the application of this thermal treatment as disruption and biofuel extraction method, and also contributed to find an operational area where high biofuel recovery is obtained. The study of high-pressure steaming as pre-treatment for enzymatic hydrolysis contributed to show that the thermal treatment didn't affect the enzymatic hydrolysis and the conversion of cellulose into glucose, and it also contributed to increase the viability of the biofuels from microalgae by the production of two different biofuels, the biocrude and the fermentable sugars, by the using of only one technology, that is high-pressure steam. Four different papers were done during this research. The first one was a review paper published in Critically Reviewing Biotechnology in 2011. The results of the first phase of the research were published in Biotechnology and Bioengineering. The results of the second phase were published in Bioresource Technologies 2 months ago, and we already submitted one paper to Industrial and Chemical Chemistry Research with the results of the last part of the research. These results were also presented in different conferences, in the Canadian Chemical Engineering Conference in London in 2011, in the second International Conference on Algal Biomass, Biofuels and Bioproducts in San Diego, and this year they were presented in the Ontario, Quebec Biotechnology Meeting in Toronto and in Research Bridges in Sarnia. The last two presentations got the first prize for oral presentation. So after the experience obtained during this research, I would suggest to do some other studies. One of them is to study the independent effect of pressure in the high-pressure steaming without increasing the temperature. Temperature may have an effect on the color of the biocrude. So if we can increase the pressure without increasing the temperature, maybe we can obtain a pure or more clean biocrude. For that, we can increase the pressure in the system by injecting nitrate into the high-pressure steaming device. I also suggest to do some experiments on the feasibility of the direct injection of the culture of microalgae after growing the microalgae in the high-pressure steaming device without harvesting the biomass. Since we found that the conditions for good biofuel recovery are low biomass concentrations, there is no need for harvesting or concentration of the biomass. So we can, or I suggest some experiments with that. I also suggest to do some experiments on scaling up the high-pressure steaming device in order to obtain larger amounts of biocrude. And the points that were found in these pieces are done in terms of intensive properties, so they are not dependent of the volume or the mass. And therefore, those points can be used as a starting point for scaling up experiments. And finally, I also suggest to do some experiments of the use of high-pressure steaming in enzymatic hydrolysis by optimization of the reaction conditions. I would like to thank Western University, Western Engineering, and NSERC Canada for the funding and the scholarship for my studies. I would also like to thank Dr. Bazzi for this great opportunity, to my advisory committee, Professor Dr. Lars Riemann and Dr. Sohrab Rohani for all the good advice, to all my teachers and professors who have been part of my education, to Brian and Sohil for always having solutions for practical problems in the lab, to all my laboratory and office mates for the good times and the good coffee breaks, to my friends in Colombia and in Canada, because you always have been there